welcome to Ladyada Halloween edition before we go out for Halloween festivities.
Yes. Okay, I gotta take these off. This is a cool Don Pedro project. Actually, it's interesting when it's green and it gets all kind of messed up looking. Cool. Check out some of the great Halloween projects that we've done over the last 10, 15 years for all your Halloween goodie needs.
Yeah, so let me just take care of biz. We're going to do stuff because we've got to jam out soon. That's why we're doing this early edition. So first up, we have our regular series of shows all week. Tuesday, JP Product Pick. Wednesday, 3D Hangouts with Noah and Pedro. Show and Tell. Noah and Pedro will be hosting that one. Ask an Engineer. We're back. Last week we had the AdaBox unboxing, which had a very spooky
And
theme.
AdaBox is shipping now. Yay, people got them.
Is shipping. This is our fall edition. We're moving things to seasons because of supply chain and shipping crises, and so the winter box will be shipping in the winter. It'll be December, January-ish, and this one is fall box. So it's some folks got it a little bit for Halloween, some folks didn't, and thank you everyone who was totally cool with that because you're a human who's in the world and understands what's going on. And then Thursday we have JP's workshop, and then Friday we have deep dive with Scott. So, Ladyada, what is on your desk this week?
Okay, so first up, do you want to mention, if you're watching this live, we have some Pi Zero 2Ws.
Oh, yeah. They're going to be gone, but go for it.
And I'm going to tell you right now, well, first off, we'll limit one per customer, please, so everyone has a chance. After this batch is sold out, I do not know when we're getting more. So if you are thinking about it, you know, pick one up, pick up another thing as well to help us out.
Nobody knows.
They're basically sold at cost. So pick up a case or a cable or something.
Yeah, buy something so this isn't the most painful thing in the world for us.
Yeah, like we love to help the community, but it is definitely Pi Zeros are an exciting and non-profitable thing to sell.
Yeah.
So
it's part of our.
It's just fine. I like to support Raspberry Pi community and people should get one and play around with it. So I've been playing around with Stemma QT boards, and finally we got that AT Tiny 817 board out, and so hold on, let me shoot this back. So with the AT Tiny, don't forget there's a board.
Yeah, flip it over the other side. So there's a board guide with Digikey. You can hold it up on your regular screen. Yeah, hold it up next to you.
Next to you.
Yeah. So if you subscribe to Make, you get this, and then I believe there's also a version online. Lots of Adafruit stuff. If you use the app, there's an AR feature, and our apps pop out into cyberspace.
That's sort of interview that we did.
And you have a little video and stuff like that. And Eben's in there, and so is
Adafruit stuff, SparkFun stuff, Seed stuff, microbits, Raspberry Pi.
Yeah,
microbit,
and I'll say this: I'm pleased about
Arduinos.
It's not a competition, but here's what I'll say.
Pimoroni.
I am pleased about.
Yeah.
So Adafruit has the most certified open source hardware. We have the most open source repositories, and we've managed to listen to the community and give them what they want, which is things in the Feather format, things with Stemma, things that has scripting languages like Python. So I think when you look at all the choices in these boards, be choosy. Pick the best ones.
Choosy,
because I think a lot of them are going to be Adafruit.
Yeah.
All right. So what else you got?
Okay. So back to the overhead. So now, we couldn't get SAMD 09s. I designed a whole bunch of boards. I had to redesign them for AT Tiny 87. And then I had to get the programmer working and get that fast enough to make it possible for us to make, quick breakouts with this chip. And also we had to port the Seesaw library, which was written in basically ARM GCC. And we ended up kind of porting it back to Arduino. So it's kind of what I wanted to do originally. And it's okay. We got there now. Working with this chip, one thing that is really nice about this chip is it's 3 or 5 volts, so you don't need an extra regulator, you don't need a level shifter. Whatever voltage you give it from 3 to 5, it's happy to run. So this board, and it's got all the peripherals you expect, analog input, PWM, et cetera, and it's fairly fast. You can clock at about 10 megahertz at 3 volts, so it's a good little chip. So this is a breakout that converts a long slide potentiometer to I2C. And, this doesn't make a ton of sense if you have a board that has a lot of ADCs. You could probably just wire up the potentiometer on its own. You don't need an I2C converter to basically one analog pin. But if you have something like a Raspberry Pi or other single board computer, or maybe there are some microcontrollers that don't have ADCs. I think the Propeller doesn't. And, the Pico only has 3. Maybe you don't have a lot of extra. But you want a lot of analog inputs. This is a nice panel mountable solution. And it's also got some Neopixels in it too. Let me unplug this thing and I can show a little demo. So I'm working on 2 of these boards. So I've got the, Metro Mini with a Stemma QT connector. And what's actually kind of nice about programming these is, I plug this into the breadboard and then I've got here, this is a USB serial adapter cable, like a standard FTDI cable, and I have that wired up to the UPDI pin. So I have 2 Arduino windows open, and one, I can run the Seesaw peripheral code, and I program it into here. So I'm like programming this device, and then with another Arduino window, I'm reading and writing the data from.
What's that weird black spot on the screen? It must be green or something. It's
Where?
stuck to the camera. See this right here? Look at this. Look at that.
That is weird.
Look at
That's on your monitor.
No, it's not, because they can see that in the chat.
Weird.
What is that?
Maybe it's
touch the lens underneath.
Maybe there's a little thing.
No, what is that? What could it be?
I don't know.
Oh, yeah, it's over there. Oh, it's the green screen thing. Oh, right, yeah. No, I know what it is. Okay,
cool. It's a little piece of tape?
Yeah, it's a piece of tape that's moved, yeah. Yeah, we have a tiny apartment.
Guys,
so anyways, it's not, you don't need to adjust your screen. Okay, sorry.
So then I can upload the Arduino code, so you can go to the computer maybe and take a look at this. So, where's the computer? So this is, I'm working on, peripheral code here in C, and then this is the code that runs on the Arduino that connects the Seesaw board and creates 4 Neopixels. And let's see if this recognized it. It did, but it's not working for some reason. Oh, because I left a while one in here. I was debugging. While this program's... So one of the things that I recently added, which I thought was neat, is... Go to the very bottom here. I added a little thing here that detects the date code, the code at which the code that's running on the peripheral was compiled. It's kind of a neat, you want to add a version number to your firmware maybe, but who wants to actually sit around and increment the number every time you compile it? And so one of the things I like to do is use the date that it was compiled as the version number, because it's monotonically incrementing. So you may not be aware, but in AVR GCC, there is this special macro called __date. And that will give you a string that is always is compiled. When you compile the code, that string will automatically be entered in with the date. And the date format is month in 3 characters, like Nov, Dec, Jan, Mar, whatever. And then a 2-digit day of the month, and then a 4-digit year. And this can be, again, handy if you want to somehow embed the date into the code so you know when it was compiled. So what I did is in the peripheral code here, I stir copy the date into a buffer, and then I null terminate it. And then I do some stir and pointer arithmetic, and I kind of go through the buffer to parse out the 3-letter month, and then I check what the index in of this month name thing to get the month, and then I parse out the day, and then I parse out the year, and then I pack that into a 16-bit. It turns out that you can fit day, month, year in in binary. You just pack it into 5 bits, 4 bits, and 7 bits to fit the year into year, day, and month into 16 bits, and then I return that value on request. I did write this code originally with scanf. I found a code online that was use scanf, and that totally destroys the amount of memory you have available on these little chips. So a little bit of stir talk, stir pointer stuff. It's one of those an annoying things in C that I always end up a project's not done until you have some string parsing going on. But this works nicely, and then, in my Arduino code, I will turn off auto-scrolling. You can see I can parse it out and say, like, hey, the code running on this board, this is when it was compiled. So I find that a little better than, like, version 1.1 or 2.3. When I have the date code, and I can cross-reference that with my Git commits to see exactly what changed at every point. Anyway, so this code, as I slide the potentiometer, the number goes up and down, and then if we go to the overhead, the code also changes the Neopixels underneath. So there's 4 Neopixels, and they do shine through the orange PCBs, so they're, you don't get blue as much, but you do get, some LED pixels. So I thought that's kind of a nice little thing. You could have a little bit of more user feedback, as you slide up and down. Maybe it's brighter or dimmer, so you can kind of visualize the volume, or maybe it is a color picker type thing. So that's the I2C potentiometer.
All right, so it says there are 2 other macros in GNU GCC for time underscore and underscore timestamp. Don't know if they're available in AVR GCC.
I like date. I don't want the time. I want the date. Yeah, you can get the time, and I've done that for like RTC setting, but I actually sort of prefer date code. I don't care when I compiled it, as long as I know what day. Okay, and then the other board I designed is this one. So let me unplug this guy. So this is arcade button to I2C. So it's got very similar that, ATtiny817 on the bottom, and then address selection and I2C connection on the top. I've got 4 vertical JST XH connectors, and those can go to arcade buttons. So these like terminal, these quick connects for arcade buttons. And I thought this would be kind of neat because it could do the PWM and the LED buttons, and maybe this would be useful for people who are like, look, I just want 4 inputs and 4 PWMs, and maybe, again, you might not have that on your microcontroller, microcomputer. You may not have PWMs available. You may not have a bunch of extra GPIO. So having that available over I2C. Okay, so then...
Yeah, and then one more thing. I guess there's also, for readable logging, you can use function name in printf from where it called it underscore function.
Yeah.
Underscore function for the macro.
There's no... Yes, of course, this will not fit on a ATtiny817. So, and again, there's no output. I'm just using the date code.
What else?
Okay, so this one, this demo, I've got, 2 buttons, and you can see that there's PWM. Supports just really, a very easy, simple board. One thing that made this design a little bit more complicated is some of these LED arcade buttons, they really need 5 volts for the LEDs. Like, you can't, the white LED actually is in parallel, so there's 2 white LEDs. So you can actually kind of power it from 3.5 volts, although it really wants 5. But the red LED version of this has them in series, and so you really can't power it from 3 volts. You need 5 volts. And so I wanted to have 5 volt power for the LEDs, not just 3.3 volts, because again, the board could be from 3, but then the LEDs I want 5. So I didn't want to say like, oh, for this one Stemma QT board, like if you don't have 5 volt power, you can't use it. I wanted to get a little booster to boost up the 3 volt to 5 volt. And so that's the great search is, how did I do that but make it very inexpensive and easy?
All right, here we go.
Yes.
Where in the world is that part I need? The great search with Digikey.
The Great Search brought to you by Digikey and Adafruit. Thank you, Digikey. Every single week, Ladyada shows you how to find stuff on digikey.com, and one of the most useful skills you can have on planet Earth right now is being able to find parts. Ladyada, what is the Great Search this week?
Okay, for this week, so I was working on this I2C, the overhead.
Yep.
This I2C adapter board that can connect to LED arcade buttons. I love these. These are durable, they're pressy, and of course they're glowy. So I've got a PWM output and a digital input that's being read. And some of these LED arcade buttons really need 5 volt power. Even if the board itself is 3 volt logic, I need to give the LEDs 5 volts for them to light up, and that's not unusual. A lot of arcade stuff is still very kind of 5 volt land, because a lot of controller boards are meant to plug into USB, and so they have 5 volts available. But since these Stemma QT boards can plug into 3.3 volt logic and power, I wanted to make sure that we had a way to give them to generate that 5 volts. And so normally you're like, oh, I got 3 volts and I need 5 volts. No problem, I get a boost converter. And I love boost converters. There's nothing wrong with DC-DC boost converters. But they're always like, you're like, how hard can it be? Before you know, you need a chip, and then you need a diode, and then you need an inductor, and then like, you sometimes even need, a compensation cap, or you need a resistor divider. And, when I don't need a lot of current, if I need only like 50, maybe 100 milliamps of current, I actually prefer to go with a charge pump. They're great for when you just need a reference voltage, if you need a small amount of current. They're not very power efficient because they always double the input voltage and then regulate it down. They're not like a boost converter where it can change the PWM rate into the inductor to change the boost voltage. They'll always double. They're doublers. The way they take the capacitor and they switch the connections back and forth, they basically double the amount of voltage. So if you give it 3.3 volts, it'll double it to 6.6 and then linearly regulate down to 5. So again, they're not power efficient, but they're really cheap, and something like this, which isn't going to be battery powered, personally, I think it's just fine. Okay, so let's go to the computer and I'll show you. So this is a schematic I have for every LED switch. So I've got the switch here. One pin connected to ground, one pin is connected to the digital input, and then over here the other one, I've got the 5 volt power, and then because I might have 3 volt logic, I have to use an N channel FET to, or you can use an NPN. In this case, I'm using an N channel FET to quickly turn on and off, or you basically connect the other side of the LED to ground. I can't do high level, not easily, because again, the logic level might be 3 volts, so I have to reference it to ground. I can't reference it from 5 volts and below. So that's a PWM controller, and then this is the switch cap. So again, I like switch cap converters because they're so simple. You've got your VCC input, and then you've got your switch cap, which is 1 microfarad, and then you've got the output, which is 5. And another nice thing is these are always, they kind of come in a standard 6-pin TSOP SOT23 package. There's a shutdown pin if you want it, but pretty much it's like voltage in, voltage out, 1 small capacitor, no inductor, no resistor, no compensation, no diode. So I'm a big fan of these. I really like them. And again, they're good up to usually about 50 to 100 milliamps. So you can drive a couple LEDs from them. So let's go to Digikey. And so finding these is a little bit interesting because they can actually be in 2 different spots. So, I usually just type in DC-DC charge pump to try to filter out all the inductor-based boost converters. So normally you'd think, okay, let me go to, PMIC voltage regulators, and that's not a bad place to start. Let's go with active, positive, single output, and the output is 5 volts fixed. So that'll at least get us, and there's ones that do other voltages, by the way. For example, if you're doing UART to TTL to like RS-232 logic, you'll want to boost up to plus or minus 10 volts. So you actually usually get 2 charge pumps, one that takes your 5 volts and gives you 10, and another one that inverts the 10 back to negative 10. So let's filter. And then let's see what we've got available. So there's a couple things. They do come in other packages, and I will say a lot of them are in the 5-pin or 6-pin category. So if I'm looking for one that's equivalent to the package that I'm using, it's going to look something like this. This 6-SOT. So let's also only look for in stock. Looks like about 56 options. But here's the thing, they're cheap. I mean, like, for quantity 1, they're 95 cents. This is probably the closest, again, that package. I originally used the AP3602. AP3602 is discontinued, but, luckily there's a lot of, crossable, pin compatible, charge pumps, but there's a bunch. So the thing is that, there are some here, but you can also find them in, I know one more thing. I just want to, before I leave, show you the current output. So a lot of them, they'll give you can, as long as you give them, again, it can't be less than 1/2 the voltage because it's a doubler, so you have to give it at least like 2.7 volts. But yeah, a lot of them will give you, 150, 120 milliamps, 60. It's a small but a fair amount of current. And another nice thing is they're not noisy. Like, you'll never get inductor noise from them. The other place to look, though, and this is the thing, you got to be careful because, I went here and I was like, I found a couple options. But also look under LED drivers. They're also, they're often considered for like LED drivers. And so even though, and I see this for a lot of DCs, like you check both locations because, for example, my OLED boost converters, whenever I look for those, the chip I use, which is a constant voltage, like the FAN 533 13 volt boost converter, it's actually sorted under LED drivers, not under voltage regulators. It's one of those things. Okay, so again, active, 1 output, voltage, 5 volts. Wait, no, sorry. Voltage output, 5 volts. And let's also only look at in stock. So there's also a couple here. And so actually the one that I'm using nowadays is this RT61 AGE. Now there's not a lot in stock right now. There's only 130 because I recently bought a reel of 4,000. But this is what I use, and it's drop-in replaceable with the AP3602, and it works lovely. Just gives you a nice clean 5 volts with just an extra capacitor. And in quantity, they can be as little as 30 or 40 cents per chip. Which again, by the time you add the inductor and the diode and the chip, is going to be maybe half the price of a boost converter, with only like 1 or 2 placements. You only need that 1 capacitor in the chip. So if you're doing manufacturing, you're paying per placement, and you're paying 5 to 10 cents a placement. It's also going to be cheaper to go with a charge pump. So this is my great search.
That's a great search.
Charge pump.
Where in the world is that part I need? The great search with Digikey.
All right, cool.
Happy Halloween, everybody.
Yeah, so if you want to see some Halloween photos from Adafruit, you can go to our Flickr photo set, or you can check out our blog. I came back from the dead.
Yeah, you avenged.
Did some vengeance.
Yeah.
This is Ashley with our TARDIS. And you can see a bunch of folks having a lot of fun. This is Sam and I.
Sam dresses like that every day, which is like the joke.
Yeah, our dress code is cosplay at Adafruit, and a lot of people do dress up every day. Kimmy was Velma Jinkies, and the Art of Electronics was a book, and she had some Scooby Snaps. So anyways, check it out. This is our mini Halloween parade and more. And then, we got a lot of Halloween stuff going on the Adafruit site. Check it out.
Happy Halloween, everybody.
And if you're going to get a Raspberry Pi, maybe put something else in the cart because, that'll help us stay alive.
Thanks.
So that's everything. We'll see everybody else during the week. Thank you so much.
Thanks, everybody.
Happy Halloween. And
Happy
that
Halloween.
is your Desk of Ladyada this week.
Get some candy.